So what is MLOps? Why is it important? Teams used to kind of look like this. You'd have like a data science team on the left and a data engineering team on the right. Data scientists would like make a thing and then they'd completely hand it off to the data engineers. And then it was the data engineer's job to like monitor that thing, deploy that thing, update that thing. So that's hard. It's hard to monitor, deploy, and update a thing that you didn't build. And so that just was rife with problems. And the first data science project I ever worked on my first company literally took 18 months to put a scikit-learn model into like a UI that was like retrained sort of regularly. That's kind of silly. And the saddest part was that when we finally got it out, it was like no one cared about the feature anyway. So anyway, so like a more this kind of goes into some of the dysfunction. So if you're a data scientist and you build a thing and you're handing off to a data engineer, maybe you ask like, hey, can you please turn my script into a data pipeline? Can you actually update that pipeline? I just changed like 2 lines. Can you go change those? Actually, can you turn it into a REST API? Can you do it again? We change the code again. Let's see. Once it's up, like how's my thing doing? What do you mean the output doesn't make sense? Why is it broken? How long has it been broken? Make this more performant. Anyway, the performance one's interesting because like oftentimes performance is like a hardware concern. Like maybe you need a GPU or something, or like more resources to speed something up. So then you would think it's more like a platform kind of person, like an infrastructure kind of person who makes that faster. But other times it could just be because like the data science algorithm is slow. Like maybe you're using too many weights in your neural network and you don't need that many weights. And so you could like shrink it down. So maybe it's the data scientist who should be concerned about performance. And the answer is it's probably both. So the data engineers, they can do all this stuff, but sure, like, can you please document how your thing works? Can you stop committing models and CFCs to Git? Can you solve dependency hell for me? Let's see. Stop bothering me. I have other teams to support because, data engineering typically has more teams to support because their value, data science needs data engineering to sort of be valuable, but data engineering doesn't. Data engineer, right back at you. You tell me why it's broken. You make this more performant. That's it. Okay, so the idea is maybe we could stop having data engineers deploy and maintain AI products, and we could make the data scientists do it. And so, like, we could just hire unicorn data scientists who like know all this stuff about cloud and data science, which is also not realistic. So when I first came to Ben Labs, the thing that got me really excited was our CTO. His name's Tyler Folkman. And actually, he's worth following on LinkedIn. I actually really like the content that he puts out. But anyway, so when he was like talking with me about coming to Ben Labs, he told me about this workflow, this way of like, it's like team topologies, I guess, like a different way of dividing up your workers to make data science a little better and faster. And so he sent me this article from Stitch Fix, and I won't read all this, but basically like data scientists, like what do they love? Data scientists love solving like specific applied problems. Like you give me a YouTube video and I'll help you optimize your YouTube thumbnails so that you get like a way better click-through rate, or I'll help you predict churn on this subscription product that we have. Like that's what data scientists are thinking about. And engineers tend to be less. Platform people or infrastructure people tend to care about that a lot less. They're just like, let me build the ultimate platform that can be reused for like all use cases. Like engineers they tend to think more in like abstractions, and they want to write something once and have it work all the time. So the Stitch Fix idea was like, maybe we could like restructure our team so that both teams can do what they love, and make this more effective. So this is a diagram by Metaflow, which is, by the way, a super sick data science tool.
Eric,
I have a shirt that I'm wearing that's branded by them.
Sorry to interrupt, but somebody texted me that there is a way to make sure that everyone can see when you share the screen. Apparently, you can adjust the frame per second, and if you adjust it to 15, it will probably consume less. Yeah, because I
can click on the.
Yeah, I cannot see after you changed it.
I haven't changed it yet. Let's see. So I see like a little screen share bubble, like, and it says 720 it says 30 FPS on it. Do I right click on that to change it?
15 or like the lower one, and probably the resolution too.
I just don't know how to change it is the thing. Like, is there a drop down somewhere? Or?
When you screen share, there should be like stream quality configurations that you can choose.
All right, I will try again. Let's see, stop sharing. It might be a limitation of me like being in the browser, honestly. That's probably the issue. Yeah, darn. Sorry about that, guys. I'll keep like periodically like unsharing and resharing. So it's just saying that enough. Okay, so what you're supposed to be seeing right now is like this metaflow. So it's a visualization that's like data scientists don't really care about infrastructure. The more you're talking to them about like compute and RAM and GPUs, like the more they sort of tune out. And like conversely, or like whatever, the opposite of that, like engineers are like they like thinking about the infrastructure and stuff. And when you the more you're talking about like the vertical use case, that's kind of when they tune out. So cool. So let's do an unshare and reshare. All right, maybe this will work, maybe it won't. But so a different way of doing MLOps is maybe you have like a platform. So maybe instead of having data scientists make something and have them handing it off to like this other team, like throwing it over the fence, it's really not good to have a group of people maintain and have to update products that they didn't make, because if you didn't make it, you don't understand it well. So ideally, you would have the person who makes the thing own the thing, deploy the thing, and update the thing. So the idea of an ML platform is somehow you take the edge off of how hard it is to use like cloud tools and infrastructure and containers and all that. And you make it simple enough for data scientists to like do that themselves. And that's kind of an ambitious goal. You'd have to make things really simple for someone who only ever studied statistics to do this. So oftentimes data scientists will have to sort of give a little bit, and they'll have to learn, they'll have to upskill as well. So if we were going to do this, you might need to have people who sort of meet you in the middle. Like maybe you have all engineers who don't really know about data science and all data scientists who don't know anything about engineering, but you probably also have people in the middle, people like the people on this call who are clearly passionate about both. And so you'll have some like science-oriented engineers and some engineering-oriented scientists, and like we could make up job titles for people like that. Maybe we could call the science-oriented engineers MLOps engineers, and we could call the engineering-oriented scientists ML engineers, and that's pretty much how the job titles work today. So yes, yeah. So like this part of the talk is more relevant to the platform, but basically like the point here is like building a platform is hard, and you can't really get them perfect right away, and so you can't like automate all the steps. Like there's going to be like there's a guy here in this picture like sitting inside of a vending machine. So like this lady is like ordering a drink, and she thinks that it's like this machine like automatically getting the drink, but it's actually not. There's a guy hiding inside of there like making up the difference, doing maybe some manual steps to get it to work. And that's often what the MLOps MLE relationship looks like. And because it looks like that, it's really important that you have like technical people on the data science side and data sciencey people on the engineering side. So okay, so what's inside of an ML platform? This is an important slide, so I'll stop. I'll like do a refresh on this one so you can see it. So this is a diagram by a group. It's called MAD. I can't remember what MAD stands for, but anyway, like this group puts out these giant visualizations every year about like the tooling spaces of like MLOps and data engineering. And look at this. Look at how many tools there are in data science. Like it's overwhelming. Oh no. Like you actually don't need to know even a fraction of these tools, but these tools do exist. And definitely for a given problem with an MLOps, you have a lot of options. And so it is actually really overwhelming. So one of the most important things that I think I can help let you take away with is like, how do you make sense of this? Like, how do you choose tools for your company, or like, maybe more relevant to this audience, like for a personal project that you might want to do, it's worth learning. So, okay. So I found a really cool company called ZenML. And I think they're a fine tool, but this isn't really much about them. The tool. This is like I found this table in their documentation, and I thought this was like some of the best thought leadership out there on like how to think about the ML tooling space. So basically, they say like these are all like sort of the components of an MLOps stack, like an MLOps tech stack, and like a functioning MLOps tech stack would have a subset of the things you see in this table here. Like a really good one, really polished one, maybe would have all of them. So there's things like an orchestrator, an artifact store, an experiment tracker, stuff for monitoring, model registry, probably terms that you've heard of before. And I took this, and then for my job, I made this this diagram. This is my diagram way of like thinking about this exact same table. So let's see. I'll do a refresh again here too, because it's important. Actually, no, I'll go to the next slide and then do a refresh. Okay, so because this is the slide, I think this is the most important slide in the whole talk. So
like the only time I saw the slide and you removed it, make it to 15 FPS so I can see it. It was so good.
Do you see the slide now? Like, does it show up?
Not for me, but
Okay. I'm gonna refresh one more time.
Guys, you know what we should do? Guys, whoever sees his screen, screenshot it and send it to the chat so I know everyone else can see it.
Oh, I can do that too. I'll do that too.
Yeah, teamwork, guys. 15.
Yeah. Also,
oh, nice. Thank you, Mert.
Ooh, Brandon, where is the stream settings icon? Like, but that looks awesome. Show my screen share. Yeah, I don't know.
I think
people. Sorry, I don't know Discord that well, so
it's okay, Eric. Why don't you focus on presentation and people are gonna just send the screenshots, so we're good.
Cool. Mert's got it. He sent it. So yeah, thanks, Mert. This is the one. So okay. I'll try to explain this as though you can't see my mouse and stuff that I'm pointing at. So like, dang, yeah, without some visual aids, it's gonna be a little harder. But if you know about tooling, you're probably you might think that this is kind of like obvious over at this section. If you don't, it'll maybe be like kind of interesting and a new way of thinking about things. What I'd really like is to spend the rest of the time maybe talking through project ideas that people have and maybe like making some recommendations off of this list. So I'll kind of loosely explain what's going on here. So you can see there's a laptop at the bottom left, and that's like the data scientist's laptop, or it's a cloud top, which is a remote workstation. But for all intents and purposes right now, like this is where your IDE or your editor is. So like that's where your Jupyter notebooks show up, and that's where VS Code shows up. It's not where PyCharm shows up because no one likes PyCharm anymore. So there's a concept in MLOps called DAG. I guess it's not just an MLOps concept, but like tools like Airflow and Dagster, if you've heard of those, like they let you define like a sequence of compute steps that you can run either on your laptop or in the cloud. And it's really good to use DAGs when you're starting to train a model or like do your initial experimentation. Tools like Metaflow. So one of the advantages of doing a DAG using a tool like Metaflow is like in each step of your DAG, you can actually choose like, do I want this step to use a GPU or not? And like getting access to GPU is actually pretty hard. And so being able to like choose which parts of your data science flow use different kinds of compute is like really helpful. So like if you're doing the first step of a data science flow is usually like I'm going to collect some data and then I'm going to like pre-process it to train a model, and then I'll train a model and then I'll evaluate my model, and then if I like it, I'll save my model and maybe deploy it. So the only part of that that often needs a GPU is usually just the training part. Anyway, so it's nice to be able to like segment your stuff like that. Also, another thing that's good about DAGs, which I would show you if I knew that you would see it, is like it's an easier way to get your code into production than starting from a notebook. Like honestly, a lot of DAG tools work in notebooks, and that's great. But the idea is if you should write your code in such a way that like you can turn it into a script later. So because like it's way harder to put a notebook in production than it is to put a script in production. So DAGs kind of like naturally push you in that direction. Okay, so let's say you have a DAG and it like grabs some data from some data set somewhere, trains a model. Where it's going to store a model is probably a model registry. So that could be like S3 or it could be MLflow or whatever. It's also probably going to log information about how good the model is into something called an experiment tracker. And so that's like MLflow, ClearML, Comet, Neptune, all those. I think it's pretty good for people to have experience with experiment trackers. I think that's like most people who come into data science have maybe trained a model on their laptop before, which is great. And I think an experiment tracker is like the first thing to play with when you're trying to like up your MLOps game. Okay, so maybe then you want to serve your model. So there's a lot of different tools for model serving. My favorite actually is Bento-ML. If you know about Fast API, Bento-ML feels a lot like Fast API. So it's pretty intuitive for people who know some Python to write it. Let's see. So, but because it's like Fast API, it uses Python as its runtime. Bento-ML does. So it's not like as performant as using, like there are ways you can export a model to not use Python at all. Like if you have a neural network, you can export it into like a neural network format like Onyx, and then you can serve that in like a C++ runtime, instead of like having to have Python involved. And also like usually performance is not the bottleneck for data science teams. Usually it's the speed at which you can iterate. And so most data science teams that I know of are totally fine to not have the fastest serving abilities and instead just keep everything in Python just because it's like really easy to iterate on. So like you could set yourself apart by going and learning like how to export stuff into Onyx and like run LLMs as fast as can possibly be run. And that's a cool like area. That's definitely a specialization, like a sub-specialization within MLOps. But you don't have to if you're like I'd feel totally fine if you're using something like Fast API. And then BentoML I would say is a step up from that. So yeah. Let's see. I was thinking about going into some of the other tools and components, but I don't know that that's a great idea. But maybe I'll just say this. So like in closing, I guess, there are, back to that original point about like MLOps is more software engineering than not, or more DevOps than not. So like, let's say you make a project and it's end to end, and let's say you train a model, you get data from a data source and you deploy it somewhere. Like, the questions I have for you then are like, how locked in is your model? Like how vendor locked in is it? Like, did you go use Modal or like, Lightning AI or like Hugging Face endpoints, one of those tools that doesn't let you leave their platform, or did you deploy it in like a very in a way that probably is going to integrate with the kind of infrastructure that companies use? Like, did you put it on AWS or did you put it on GCP or something like that? Like, the AWS GCP answer to that question is a lot harder, like because you actually have to know about networking and maybe like infrastructure as code and permissions and stuff like that. So it's a lot harder. And most of that skill and knowledge is like software engineering skill and knowledge. Like, how do I write IAC? How do I set up a VPC? Stuff like that. And so I feel like when I've interviewed people, I do get a lot of people who are really excited about ZenML or Metaflow or like just cool MLOps tools in and of themselves. And I feel like this isn't a trick question, but I just asked them, okay, like let's say you use that tool, how would you integrate it with like a stack that's running like containers on AWS? Like let's say we have some servers on AWS and we want to hit the service you deployed. Like, how are we going to do that securely? Like a lot of people like that's not, if you're familiar with AWS, it's actually not too hard of a question. There's a lot of good answers there, but if you're not, I don't know, like if you don't have that background, you might just be stuck there. And the difference between being able to answer that question and not being able to answer that question is almost like a year of experience in like just in cloud infrastructure. So like, anyway, so I would say it's a lot easier to go from like, I'm a cloud developer, I'm a cloud engineering expert, to getting sort of like an MLOps specialization in that, to like, it's a lot easier than the reverse, which is like, I'm kind of a beginner at this. I'm going to learn the basics of some MLOps tools. And then I'm just going to hope and pray that like the tools that I use will like work in the cloud or like be scalable and stuff. So one example of that, this is like ML monitoring. ML monitoring is like a big hot topic in ML. It's like, how do you monitor machine learning models? How do you make sure that like the models aren't drifting or like models aren't giving like lies output to people? And so there's a lot of ML monitoring tools that like can look at like ranges of outputs that you're giving out. Like the common example is like in COVID, if you shopped on Amazon.com, Amazon.com was probably recommending you like hand sanitizer and toilet paper, and today if you shop on Amazon.com, if all Amazon recommended to you was hand sanitizer and toilet paper, you'd be like, what the heck? These results are totally irrelevant. But like, so that's an example of like model drift or data drift. Like that model trained during COVID, the model probably is really good at recommending hand sanitizer. By today's standards, that model is probably stale. Great. So advanced fancy data monitoring tools like Arise and Ylogs and Aporia, they can help catch that problem. But there's actually much harder problems that are more related to software engineering that are probably more likely to trip you up. So like let's say someone goes to try to hit your service and it's just down, it just crashes. Like that's not really an ML monitoring concern. That's more of a software. That's more of like how do I keep a REST API up and working in the cloud? I would say that's a more common issue than like model degradation and model drift. By the way, if retraining models is cheap, you can solve model drift without any fancy tools by just retraining your model regularly. So like actually fall under that umbrella. It's like totally fine. Like, oh, our product got some new data, so let's just retrain our model today. Like if it's a scikit-learn model, that's like pretty cheap to do. And so the instant you can do that, you no longer need to spend like 60K on one of the fancy like ML monitoring tools. But what you still need is good like software monitoring stuff. So that's like, if you've heard of OpenTelemetry or Datadog or New Relic, like how much RAM is my service using? When I send data to my service, am I sending it NANds? How much CPU utilization is my service about to run out of memory? When I get an error from my service, am I easily able to take that request ID and look up the logs in the service so I can find exactly like what part of the code made it fail? All those things are actually classical application monitoring things that senior software engineers kind of know about and set up all the time. And it's kind of like the 80-20 rule. 80% of the value of ML monitoring can actually I would say comes from just application monitoring. And so it's like, okay, if you came into MLOps and you only learned like the MLOps part, like the ML monitoring part, you're only equipped to solve like maybe 20% of the value of the problem. Unless that's not true, unless it really is like a high risk model like fraud detection or something, in which case you still need both. You still need the uptime question, the data quality question, and you need like the ML monitoring part. So anyway, so this was all sort of a long tangent to say like, when I put a poll on LinkedIn, I asked people like I was thinking of leading a boot camp. I might do that in like June or July. And I had 3 course ideas, and I let people vote on which course idea they thought was most appealing. And I was like, we could do advanced infrastructure as code and networking on AWS. We could do REST APIs on AWS and how to monitor them, or we could do MLOps and like just do only the training and serving part. And I just thought it was really funny because like by far people voted for the MLOps one, and I was just like, I don't know, like I'm probably making some bad assumptions, but my initial reaction to that was like, you guys, like, you don't understand, like 80% of MLOps is actually just DevOps. So like, I don't know. So and by the way, I think the DevOps part is often a lot harder because I do think the MLOps tools are getting like a lot easier to work with. So that's my rant. Those are my hot takes. I was hoping to show more code examples, but I don't think that's going to work out with the screen share. So at this point, I think I went on longer than I was planning. Okay, yeah, so we've got like 15 minutes left. So do you want to just do Q&A? Like, is there a project you're thinking of working on, and do you want like recommendations on a tech stack? Like, do you have career questions? Like, I'm happy to help with any of that.
Yes. We do have all those questions, and thank you for sharing amazing slides. I'm glad people were sharing the screenshots for those who haven't seen it. But I did have a question to begin with. So we're starting this 30-day ML challenge for the community, and this is exactly what we're building. And I'm so glad that you came here today because, like, can you tell us what are the like basic fundamental steps to build and deploy your model, and how can we do it in 30 days? And what are the tools that we could use? Like, if you could just break it down for us, that would be a great start.
Totally. Yeah. Training and serving, I think, is actually the easiest part. Like, I think the hard part is like the networking, the auto scaling, the monitoring, and like maybe like where you like data management is pretty hard too, the data engineering part. So I think you can definitely do the training serving part in 30 days. So, and within 30 days, it's not like you can expect yourself to like become a master of DevOps and AWS, you know? So I think if 30 days is the time scope, then I think using like off the shelf vendor tools is totally fine. Like just to get it, you know, like I see a lot of influencers put example projects online with like Common ML. And I'm like, when I see that, I'm like, okay, Common ML is like in the hundreds of thousands of dollars a year for a company. Like, I don't know if I would choose Common ML for work, but it is easy to get up and running with if you're just a beginner trying to get a project off the ground. And so like using tools like that, you know, if they can help you get a sense of the big picture. So, but they're not necessarily the tools I choose at work. So like, so I would say you don't even need a fancy orchestrator or anything like that. Like, you could train a model locally using just a Python script, like just save a pickle file like scikit-learn or something. LLMs are not so different. And so at that point, I think the serving part is the most difficult part. So I really like BentoML. I don't know. I'll try to share my screen. So there's a lot of SaaS tools that have like a free plan. You can go use their SaaS version. So I like BentoML for work and personal things because like I know I can always host it myself and host it in any AWS account or GCP because it's just Docker containers. But they also have like a SaaS tool you can get started with pretty easily. So let me show you. So yeah, hopefully you see this. So let's see, Bento Cloud. Yeah, if you Google Bento Cloud, it'll show up. So I don't know, I hope my screen doesn't freeze, but it's loading.
So Bento Cloud allow to store the model on their platform, or do we still need to have a cloud like GCP or?
It does actually, yeah. So yeah, maybe I should like give some context of Bento, like. But here, let me show you this. Let me show you this UI first, and I think it'll give you a sense of what it looks like. Let's see. Oh my goodness, internet's so slow. All right, well, cool. This is fun. I have like a personal login and a work login, and it's pretty cool that I can like switch between work and personal like easily like that. Okay, so let's say you wanted to just use like Fast API. Like the simplest way to get a REST API out there is probably Fast API. And so like you'd probably write a one file big app, which is like your Fast API app with like an inference endpoint. And maybe like on startup, you would like load your pickle model into memory, and then like your inference endpoint would like use that model to like run inference and return it to the user. So then there's a few questions there, like how do I host it? Like, you probably have to put it in a Docker container or like and like put it on any platform that can like run Docker containers. And so like AWS Lambda does that, AWS ECS does that pretty easily. Yeah, so Bento kind of works similarly. Like it also has a, see, I'll try logging again. So it also has like a Python SDK that feels a lot like Fast API when you use it. And you write this like Python file, and then you get your scikit-learn pickle or whatever your model weights are, and you actually zip those things together. You create a zip file that has like your serving, your API code, and like your model saved with it. And Bento Cloud actually kind of can be a model registry, not an experiment tracker, but it can be a model registry. So they have this like models tab, and you can take your scikit-learn model and you can save that and you can upload that straight to Bento ML, which is like kind of nice. And then it'll have like a model ID. And then later when you want to build like the zip file that has like your serving code and the model together, that's called a Bento, and you can like upload those and they show up in this blank UI that you can't really imagine how this works. And so when you have like this zip file together with your serving code, you can come over to like deployments and like you can create a deployment by clicking like a create button, and you click one of the bentos that you made, and on their side in their cloud they will do the work of taking your zip file and building a Docker image out of it and just like deploying it. That's pretty nice because they have their cloud supports like using GPUs, and so honestly, I bet you could get a basic model trained, saved, and served on Bento Cloud in like under a day if you spent all day on it. Like maybe 3 days. Like if you're totally new to this stuff and you want to like immerse yourself in the docs. So then if you want to like take your project to the next level, then I would say try setting up an orchestrator. Like probably the easiest orchestrator to get started with right now is ZenML. I wanted the answer to be Metaflow, but I think Metaflow is definitely, they have an easier story right now for like enterprise. But so ZenML I think is the easiest one to get started with, just like open source. So you could use ZenML to like write a DAG to train your model. That'd be awesome. And then another good area to explore is like GPUs. Like using GPUs is actually pretty hard because like you have to get your GPU drivers just right. If you could train your model using GPUs, that would be kind of impressive. That'd be pretty cool. Like ZenML could, with some work, and if you worked with the ZenML community, ZenML could help you like deploy your training DAGs to AWS and get access to GPUs there. That would be pretty sweet. And then with Bento Cloud, you can pick the GPU driver versions that you want to use, and you could get your endpoint to then also use a GPU in production. Anyway, so that's like my easy mode recommendation, and I think I like this recommendation because ZenML and Metaflow, and I think they're the two dominant like DAG orchestrators out there right now for ML. So if you're able to get ZenML this far along, like even if it's not the most robust, you're using tools that can be robust. And so I think those are cool to talk about in like a job interview setting. And the same with Bento Cloud. Like, yeah, you're just using Bento's managed cloud right here. Sure. If you really wanted to, you could take this Bento, you could deploy it yourself on AWS for free. So this also sort of like, I like this recommendation because the same tools you use for your personal project, you could also like use at work, and I think people like that. So, sorry, long answer. We got like 9 minutes. What else? Let's see. Can you reference a source to install GPU drivers properly, please? Ooh, I can try. I think you should learn about NVIDIA Docker. Like, and maybe you already know about this, so maybe that's a frustrating answer. Like, because like if you don't know, to use GPU drivers, you have to install GPU drivers like on a host machine, like on the machine itself. And then if you build a Docker image, the same version of the drivers has to be in that Docker image. And so it's this really annoying problem where like you're trying to sync stuff. The image you build in Docker almost needs to be like built with the exact target hardware in mind, which makes it kind of hard. Yeah, if you learn about NVIDIA Docker, they can help you get the Docker image part of that together. And then I don't think there's like a great official way to install CUDA drivers onto a host machine itself besides just following the NVIDIA docs. And I don't know, it's hard. Like it's actually pretty hard to do that. So I think, is it even worth it to like I have a like GPU machine right here, like under my desk, and it's got like a 3090 in it. And I thought I was gonna train models with it. Sorry, can you guys hear me?
No, we can't see you. I don't know if that's me or.
Sorry, I board so I could show you. Let's see. Stop sharing. We're back on. Anyway, I was just you may work, but I tried to show you my gaming PC, which has like a NVIDIA 3090 in it. And when I got it, I was like, I'm gonna use this to train models. Then it ended up actually being really hard to like get the right CUDA versions onto it. And I realized like that would take a lot of work. And honestly, that is a cool project. It is really, really cool. But I think an easier way to get started is create an EC2 instance in AWS, like one of the GPU ones, because that'll come with the drivers already installed. And honestly, when you run stuff in production anyway, you're pretty much always running it on EC2 instances or like the Google Cloud equivalent of that. So like, yeah, so GPU rich. Yeah, I am because I have 3090. Yeah, so learn about NVIDIA Docker. That's like really cool to see. Like I'm personally really bad at using it and I always have to ask other people to do it. So it's like if I were interviewing you today and you were great at NVIDIA Docker, I'd be like, dang, like that definitely rounds out a weakness that I have. So, and it's not like it's hard to, I mean, it is hard, but like, it's not like it's not within reach to learn about. So,
I
yeah,
have
what else? Let's see.
Eric, since you mentioned that you do a hiring process too, what is the tech stack that people need to build, and what are the skills that you focus on?
Oh man, that's I kind of like I had that question in my mind the whole interview, and so like so my answer is kind of like the presentation I just gave. It's like there's not really one tech stack. But one thing that does like really rub me the wrong way all the time is like when people just don't have a foundation in DevOps or like infrastructure as code on AWS, because it just means that like the second we have problems with a tool we're trying to use, it's the whole workload's going to be back on me to try and troubleshoot that problem as like someone who's a cloud engineer. So like, so yeah, like I look for like decent experience with like a project like this, like exactly what I'm talking about. Like, have you used BenchML? Have you used NVIDIA Docker? That's pretty cool. Like, have you used an orchestrator? Even better if you've like set up an experiment tracker and remote workstations. Like, you know, there's ways you can check off all the boxes in that table that I showed you that aren't too hard. I really like to see that. But if you don't have a really strong foundation in like cloud engineering, like you can't be on my team, which I think sounds harsh, but like just in general, ops teams tend to be really heavily weighted towards senior engineers. And it usually happens to be senior engineers who like have done cloud engineering before. But at the same time, like I personally learned a lot of the cloud engineering stuff, just like taking Udemy courses, like going to boot camps, like building like my personal project Rootski and stuff. So like you can totally learn this stuff on the side. And honestly, if you do, you'll probably end up being one of the most knowledgeable people about cloud engineering where you work. So I think that's kind of reassuring.
And what's the difference between engineering and MLOps, would you say?
Oh man, I kind of made up a difference. Honestly, a lot of people use them interchangeably, so maybe that's the actual answer. But in my view, the MLOps engineers are very ops focused, and they stand up the tools for ML engineers to use. So like, if you have a data scientist who's like really good at engineering, they're probably going to be really good at using your tools. I want to give you like a concrete example, so it's not like vague. Like for example, we gave our data scientists an infrastructure as code module with a tool called AWS CDK, and it felt a lot like Docker Compose. It was like we gave them this Python class, and if they filled it out, it would deploy like a REST API onto AWS. And that worked great for the data scientists, but for most use cases. But some use cases, they wanted to like tweak the infrastructure a little bit. They wanted to like up the size of the RAM of like the REST API. And it was like, the MLEs were technical enough to like be able to do that themselves or be able to like have good conversations with us to tell us how. So I kind of am viewing them as like extra technical data scientists who like have more of the background that we're talking about here.
Cool.
Yeah, honestly, I mean, we're almost at time. I'm down to stay on as long as people would like to. If the event's officially over, it's 5 PST. So that's cool too. I mean, anyone can cross it.
No, it's okay. We have some more questions to go over. It says Madhav is asking, what would be the level of MLOps would you say people should start with? How people can transition from one level to another, like from beginner to advanced, I guess.
Cord term. Like, I'm just kidding. Yeah, well, you kind of have to start at the noob level. I mean, don't we all? Like, so in my mind, what that looks like is maybe pick up a tool like ZenML, which is easy to run locally, and try to get a DAG tool to run locally. Actually, even more noob level, like train a model yourself with just a Python script and save that as like a pickle. Like do scikit-learn. Try to like get that deployed on the cloud, like do within a day. From the advanced by like standing up an orchestrator and starting to add components. And the more components you add, the closer you get to like legendary. But then of course, you're not really legendary until you can actually deploy all this on the cloud. The way that you would like it's one thing to stand something up on the cloud. It's another thing to like own that in production. It's like, oh, you know, like I deployed this REST API and it exists, but today it's having mysterious errors and I don't know why and it's crashing and I have to debug it. And it's like, you better be good enough at your tools that that situation doesn't scare you, you know? Like, and maybe that just means you learn a lot of monitoring. I feel like that is really the difference between like the experts and like, you know, people who are just like getting into it, like the mid levels. So. Yeah, ¿qué más?
And Mert is asking, do you think learning CUDA is worth it, or like becoming specialized on infrastructure side worth it?
Man, you know, yes and no. Like I talked to a guy who his job title is literally GPU engineer, and actually he doesn't work at BentoML, but BentoML was telling me they are also hiring someone whose job title is basically GPU engineer, and like their whole job is to like make it so when you use BentoML, it like very in an optimized, like the most optimized possible way, like leverages like your GPU. And so you can imagine if you're like an expert at CUDA or GPUs, like, you know, you're kind of in a different class as far as like that specialization. Like you're probably one of the only people in the world who could like be a GPU engineer. So it's like, you could probably be a GPU engineer without being an expert at MLOps. So it's like, do you need to do it? No. I mean, I don't know. Like, I don't know that you need to do anything. I'm just saying all these things help. And like, if you were a master at all of them, which I am not, then you would be a master engineer, and like pretty much no one is. So the more things you learn, the more hireable you are for the right group. So I would say, like, I definitely think it's great if you could successfully install CUDA, and or pick up an EC2 instance that already has that installed. If you could get something running in NVIDIA Docker, that's pretty cool. Like that's a pretty common problem that a lot of people don't know how to do. But the immediate next problem though is like when you use an LLM or like Stable Diffusion, those models are super video RAM hungry. So like video RAM is a special kind of RAM that like GPUs use. And very surprisingly to me, like I wasn't expecting this, like picking a GPU size that like has enough VRAM or knowing how to optimize a model so that it doesn't use as much VRAM, that's like once you start using GPUs, that becomes like the problem you solve like every day on your job. Like, okay, I'm using Stable Diffusion and I'm running on a VRAM, which means I can't generate image for all my customers. So now I need to figure out how to consume less. So maybe that means like quantizing the model. Maybe it means like shrinking the hyperparams in the model, something like that. And so like the second you have a GPU to start playing with, if you can start learning how to optimize models in that way, that's like a solid skill. That's like, I noticed when I was interviewing places, I have some experience with that, and that was one of the areas where their eyes like lit up. They were like, "Oh my gosh, like you know about GPUs!" Like, and not only that, you've like gone a step further, and we haven't even used GPUs ourselves. And so like that's definitely an area where people are hungry for right now. So
Eric, would you say Discord engineers need a GPU engineer given our quality of today's conversation? I don't know if it's really.
I don't know. I mean, I'm using the web app. It's probably like Brave or Chrome needs GPU engineer. Like,
yeah. That is so
Let's
cool.
See. I'll like go back. So
yeah,
Amit asked about refactoring skills. Yeah, those are important. You should be good at writing like readable code. You know, like because that's like I just feel like that's one of the easiest things. Like that's something like readable code is something you can like learn yourself by taking my course, taking other courses, building stuff, asking ChatGPT to refactor it for you. You know, like there's ways to learn that, and it's like there's so many data scientists who've been working 4 or 5 years who are great at data science who are just bad at that. And one of the things I said earlier, that one way you can get into MLOps is you can start as a data scientist and transition laterally. So like that's just one of the easiest possible ways to like differentiate yourself from other data scientists. Just be able to write clean code, I think, and be able to extract. Like people talk about this like it's really hard. Like I've seen whole courses on like how to take a Jupyter notebook and extract your code into a script, and it's like that's actually not that hard. Like if you've written non-trivial scripts before at all, you know what to do. And so like anyway, so someone else asked, I have another question. How do you manage to memorize new technology and new tools? If you came across an article or post that demonstrates the implementation of a new technology, would you grab your IDE and implement a small project? Honestly, because there's so many tools, now I only grab tools that I actually like want to use for a specific thing. And so yes, once you've built a thing with the tool, you'll remember how to use it. So but beyond that, I mean, I would just like all the logos I showed you today, like I know at high level what all those do, but I haven't used all of them myself. And that's pretty much what you need. Like if you can go deep on any one of the tools in every category, like you are ready. Like you will be able to transfer to any of the other tools, you know, the components at any time. So let's see, someone else said, new references source to install GPU drivers. Yeah, use brev.dev notebooks. Ooh, what's that? To fine tune your model. And there's a lot of notebook and remote workstation tools out there, honestly. Let's see. Yeah, Mert said fast API deployment would be cool. If it's true, fast API deployments are cool. Actually, let me tell you why BentoML is better than fast API for machine learning specifically, because actually fast API is amazing. It is like across all programming languages, it might be the best REST framework out there in terms of like ease of use. It's just so good. So it was actually really sad for me to leave it for BentoML. And so I actually haven't fully left it for BentoML. I've only left it for like machine learning use cases because BentoML happens to be really good at machine learning use cases. So remember the video RAM problem I was talking about? Well, like what the way fast API works is like Python doesn't do multi-processing, right? So like if you want to be able to handle 4 user requests to your API at the same time, and the way Fast API does that is you literally run 4 instances of your Fast API process at once, and that determines the max number of requests you can handle. And so guess what? If you want to like run Stable Diffusion in Fast API, that means you're loading Stable Diffusion into VRAM 4 times, because once per instance of Fast API, which means like most GPUs, or like in the use cases I was looking at, could only handle loading it once. So loading it 4 times was just like a absolute like what do you call it? Like showstopper. So what BentoML does is it's still Python, but they only load the model into memory once. And then they have different web server processes working, yes, but those processes all share the same model copy. And also what's really cool is like as requests come in, models are really good at handling inferences in batches, which is to say like doing inference for 4 inputs is pretty much the same latency as doing inference for 1 input. And so what's cool about BentoML is it'll take these individual incoming requests and it'll like batch them into a list and then pass them all to the model at once. And then it'll like break that out and respond like the individual things back to the people who requested it. So anyway, so that makes it like really performant and stuff. Let's see. Mert, you stayed up till 2. Mert, you're always staying up all night. Oh man, Amit, where are you in the world?
Wow, we should really make these events international.
I think 8 a.m. or Mountain Time or 7 a.m. like Pacific Time usually is good for people in India and Europe.
7 a.m.
I know it's good for Mert. So let's see. Yeah, I'm down to keep going if anyone wants. Indians always beat me. Mert.
Yeah,
you guys. I hope you'll connect with me on LinkedIn. Sorry, go ahead.
Yeah. Well, we can share all of your stuff here actually before we forget. But Eric, I was wondering, what are the career opportunities in MLOps you see?
There's MLOps engineer. I'm just kidding. Yeah, like so. If my company had layoffs right now, like I guess one, the space is pretty good for senior MLOps engineers. So like, I got options. Like, like it's kind of nice. Like for me right now at this current market, I'm not too worried like about finding another job. That could totally change in a year, but right now it's good. But even within that, let's say I didn't have options, like skills are very transferable. Like I would say I may be one of the best infrastructure as code engineers around, and so that's a good set of skills. Like that's you could be on a DevOps team, you could be on an SRE team, you could be on a software engineering team, full stack. Like no concerns there. Like that's a really good set of skills. Like cloud engineering is just a really good set of skills, and so no wonder if you have that skill set, you're really well positioned to go into MLOps because it's actually just foundational these days. Let's see. So yeah, I guess if you're a good MLOps engineer and you have a strong software engineering foundation, then the only area of engineering I think might be hard for you to get into is front end, because front end is just so different from because basically a lot of the MLOps skill set is like back-end engineering, so data engineering is somewhere you could pivot to, data analytics, analytics engineering. I'm not saying that there's no specialization you have to do. I'm just saying these fields of engineering have like a big, a shared core, I guess. So, over here, you said I have great energy. Thanks, man. Let's see who else. Eric, what would you do if you're in fourth grade? If you're a fourth grade student from Turkey or India, your goals are to come to the USA. Is fourth grade like? When I think of a fourth grade, I'm thinking of like a 9-year-old. Like, is that what you're talking about? Like, and you want to come to the USA? Man, I don't know. Like, I just feel like it's so hard, because one, it's so competitive for entry levels, right? And two, if you're an entry level and you have to like be in the H-1B process, it's just so hard. Like it's just so hard to break in. Like you have to be such, in my opinion, like a strong engineer in any category before someone's willing to like sponsor your visa. I feel like is the main way I know of to come to the US. But at the same time, I do have friends in the US who are like in the entry level position and they're international students or they're international workers and they're worried about losing their like their status as like being allowed to be in the US. And like honestly, what I would say, like, it's one thing if you have family here. I mean, that's really hard to be separated from your family. But if the job market is your only concern, like there are good tech companies all over the world. Like Canada comes to mind, Germany, let's see, is like ClearML is based in Tel Aviv. Let's see,
Netherlands.
Like, yeah, that's true. I guess there's just a lot. Like, yeah, that's true. Like, I think Maria Vechtamova is
yeah.
I want to say she's in the Netherlands, right? Like,
there's
anyway, so like,
Sadhan
Secret is
has
getting more like you, a strong engine. Sorry, what?
A lot of large-scale projects tend to use streaming or event-driven architecture. Does it help to learn Snowflake as an MLE, or is this something that the data management folks take care of?
Data management folks for sure, but like, you should be able to like, you should know SQL, you should know how to query stuff. And so I guess the project I told you about, like train a model and then deploy it to Pinto Cloud, like another way you could level that up is maybe like learn a database. Like Postgres is a good database. And like Postgres doesn't scale forever. And so that's when you get into like data lakehouse land, you're using like Databricks and Spark and all that. But like the underlying principles of database management are, really similar, like again, a strong core. And so like, if you know one database, and again, I think the database to know is Postgres these days. I think that's really good exposure. And I guess one of the reasons I say that is because that was my background. Like I stood up Postgres and I knew some things about it and I'd like run it in production for a bit. And so like, I had like had to solve some outages myself. And I've noticed that like the same things that I had to do roughly, like learning how to do backups, learning how to monitor it, like learning how to make it highly available, like those concepts have been the same as we've like started to build our data lakehouse where I work. So I don't know, there's that. Okay, I'm gonna cry after this question now. You can spot me and cry. Wait. What's your question, madame? Oh yeah, just responding to Mert. Like, oh yeah, but going back to the international student thing, I just want to say, like, if it is about like getting your first job, like, I know the U.S. has really cool tech companies, but so do so many other parts of the world. And for example, like, I know, for example, that Germany really wants, like, a lot of these countries really want qualified tech workers to come in because qualified tech workers like earn an income and contribute to the GDP and like generally lift the economy as a whole. And so there's like, I feel like a lot of other countries are much more friendly to international workers. So, I don't know. And the US is great. I love being in the US, but like, there's lots of places that are great. And, so, maybe you could come later if that's something you really want to do. Like definitely once you've like gone and made your fame and fortune in the MLOps space, like there'll be all kinds of companies in the US that are after you. So like, no dissing on the USA. Yeah, Utah's great. Actually, Utah and the USA has like a surprising like if you know Ben Taylor, like he is here or was here, or like Travis Oliphant, the creator of NumPy, created NumPy at my university, Brigham Young University. And let's see, like I don't know, Matthew Sharp and Chris Brousseau, they're writing the MLOps book. We got them. Joe Reese, he wrote the fundamentals of data engineering. Like, I don't know, Utah has kind of got like a habit in data scene. It's actually pretty cool. like, um, and of course it has Mert virtually. Let's see. Oh, so Donna, I missed your question. Okay, a lot of large scale projects use streaming or event driven. Oh, you're right. Sorry, I was gonna answer this. So is that worth learning? Is it worth learning Snowflake? I don't know. Maybe. Like I think the database concepts are good. Is it worth learning about streaming and stuff? Potentially. The thing is, like, it's one of those areas where like 80% of companies just aren't even there yet. Like a lot of stuff like stays in the batch world for like a long, long time. And for job interview purposes, like, yeah, if you've set up a streaming project before, then, you know, you can be appealing because it's like, oh, we don't need streaming now, but maybe when we do, if we hire Sedona, like, you know, she can help us set it up. So, like, it's cool, but it's just like, at the end of the day, someone could have had a streaming project, but not know about like batch and stuff or some of the fundamentals, like how to stand up an experiment tracker. And I would take the person who knows the fundamentals. But at bigger companies like Spotify and stuff, like they use streaming all day long. And so, like, for bigger, more established like SaaS companies, like yeah, streaming starts to matter more. And so it's just like I don't even know which one has more job openings or which one, you know. So I'm not sure. I don't know that I can give good advice on which one to target, like what kind of company to target. But I can say that if you learn the batch world, it's relevant everywhere. If you learn the streaming stuff, it's only relevant at like bigger shops. So
Right. Also had a question about like the teams. I was wondering what are the roles that are in your team? Is there like a data engineer, data analyst, data scientist, ML engineer? Who is responsible for the entire flow?
So I think Ben is like pretty enlightened, you know. So like I think we have job titles that are the way that I like them to be. like because sometimes I look at other companies and what they call an MLE is just not what I think of an MLE at all. Or definitely with data scientists. Like I interviewed somewhere and I was like, "Are you a data scientist?" And like, "I don't even know what a data scientist is. I'm an MLE." And they were like, "I think I knew a data scientist once. Like I think those are the people who like make dashboards or something." So like, so data science can often have that connotation of like analyst, you know. Sorry, I totally distracted. What was the original question? Oh, what are the roles, right? So where I work, we got like an ML platform team, and that's me, and we stand up and maintain like Metaflow and Bento ML and an experiment tracker. So we like get those tools ready, and we make like project templates and remote workstations, and make sure things are highly available. And then we make like guides that the MLEs and data scientists can follow to then go use those tools themselves. And so then they use the data scientists and MLEs use those tools and they like deploy their own stuff. And in the ideal world, we don't even know or see what they're deploying. Like they're just doing it. It's kind of like if you were using AWS Lambda to write a REST API and your REST API broke, like the only reason you would reach out to the AWS Lambda team is like if you had a bug, if like AWS Lambda was broken. But chances are that's not what's happening. Chances are you're just using AWS Lambda wrong. So like, so that's kind of our team dynamic. Like we stand up the tools and like we give guides to the data scientists and we're like, good luck, like go. But in practice, like we want them to have a good experience. So we often will like pair with them. That's actually one of my favorite parts of the job is we'll like pair and mentor with the data scientists and stuff who are like less technical and we'll like help them learn the tools and get there. Let's see. And so that's like, and so difference between data science and MLE. MLEs, we expect to like be able to use our tools really well and like give us some thought leadership and how to make our workflow better. Data scientists, it's like, okay, we're going to give them the tools and we're kind of not expecting them to do the most advanced things. And like the MLEs are sort of expected to help them. And then we have that exact same relationship for data engineering in a team called data acquisition. So data engineering stands up Spark and Databricks, and like instead of using Snowflake, by the way, actually this is a really interesting thing. Snowflake is great. The thing that was great about Snowflake originally is that you could separate storage from compute. So you can have this massive data, you can put it in S3 buckets, which is like really cheap. You only pay Snowflake when you like are running queries against that data, so you're paying them for compute. And I don't know if Snowflake does this, but Snowflake sort of opened the door, I think, or companies like Snowflake opened the door to tools that were similar. Like you're a company, you store your data in S3, and then there's many companies you could pick from: Snowflake, Databricks, Firebolt, and other companies that sort of act just like as a compute layer. And so there's this exact Wilson, the influencer, he talked about this all the time. So there's these new fancy file formats called Apache Iceberg, Apache Hudi, and Apache Delta Lake, which is by Databricks. And those are basically like, they're kind of like Parquet files or CSV files. They're like a really compressed way of representing like tabular data. And if you store your data in those formats, you can go pick like a variety of different vendors to go query that data. So anyway, so by the way, if you're looking to like do a really impressive data engineering project to like feed your model, they call that a data lake house. It's a data, once you start using S3 and storing your data in that format and using a separate query engine, that's what they call a data lake house. So if you stand up your own like mini data lake house, I mean, that's actually really impressive. And to be honest, I don't know how hard that would be. Oh yeah, Parquet and Avro files for the win, for sure. For sure. To be honest, I don't know why Parquet isn't like talked about with Apache Hudi and Iceberg and the other one. Like, so because I feel like Parquet was really great, but then people decided we needed these other file formats. So I actually don't have a lot of context there, but so that was sort of an aside. But yeah, the data platform team, like they're the ones who picked the file format that we're going to use. They stood up the compute engine. They have a DAG tool called Dagster, which is like a more data engineering specific DAG tool, Spark, stuff like that. And then there's a data acquisition team, very similar to how the data scientists act with us. They go and use those tools and they make a bunch of data pipelines that make a lot of money. So yeah, what else? Ask Eric if they hire interns. Yeah, if he can book. I know. I really, 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 really wish we hired interns. Like right now, we're kind of on a hiring freeze. Like, yeah, it's like I feel like I get that question a lot. And I'm just like, man. Like sometimes people ask, like, do you have any leads on how to get a job? And I'm just like, no, because usually the people who are asking are entry levels, and it's just like I just don't even know where to get an entry level job, honestly. And especially depending on the country you're in and the market you're in, like factors. Advice I could give you could be totally off. So, but I think LinkedIn's a good thing to do. I think you should be on LinkedIn. I think you should be like, don't spam us. You know, I think there's a lot of entry levels who like turn into influencers right away. It's like, dude, like, do you know anything? But occasionally, if you can just share something you're learning about on LinkedIn, and just like, you know, you connect with people, follow people, and just participate on there. I think that does help. But even then, I think that's getting kind of saturated. So do that, but also do go to meetups wherever you are in the world, and also virtually, just go to meetups for sure. Also, I'm hearing more and more people talk about how they got their first job by contributing to an open source project, and then the creators of that open source project hired them. So like I met 3 people like that at Outer Bounds for Metaflow. I met one person literally yesterday who did that for a company called Dagworks. They make a tool called Hamilton. And that's not a guarantee, and time is risky, but I will say one of my big things is you should learn about software engineering. Contributing to open source is a good way to do that, because like basically when you're contributing to open source, you're writing production code and you're getting mentorship from senior engineers, which also means you're consuming their mentorship time. And so like you better act on their advice and be valuable. Otherwise they'll drop you and you'll actually have done more net harm than good. But if you're willing to like, don't overstretch yourself, like commit to one thing. If the one thing you're willing to commit to is contributing to like one open source project, I think that's like really solid. Like I think that's a really good way to prove your value. And like, and even if that doesn't pan out, you'll have learned a lot. That's something you can put on your resume, and that's absolutely real live work experience, even if you weren't paid for it. So that's something you can like talk about in job interviews too. Stay in the tech industry for 1 or 2 years and you'll start getting white hair. Yeah, I know, fake your age. Honestly, I hope age discrimination isn't as much as a thing as they say it is, because I'm like, man, like I don't know, like, because I've noticed, like, I've been working for 6 years, right? And like, that's kind of, in the grand scheme of things, actually, that's kind of a long time. Like, that's actually in like the upper percentile of like tech workers, because I feel like there's been such an influx in tech workers. I'm like, man, I really hope that when I'm 40 years old, people don't treat me differently. Like, let's see. Lots of LinkedIn DMs and cold. Oh my gosh, Ahmed, don't cold LinkedIn DM people. But if it worked for you, I guess great. It's so annoying. Like honestly, I may have done this to one of you guys. I might have even done it to you, Ahmed. Like, but if you cold message me your resume, I'm just like, man, all I'm gonna say is I don't have any leads and good luck. Like. But I understand why people do it. Like I understand that like times are hard and that it's a way that it can work. So thoughts on unpaid internships? Yes. Honestly, I would have paid money for my first internship. Like I really would. And I know that's like Oh yeah, Madav, that's a good point. Only if you're desperate. I was desperate, so like, I needed extra help breaking in, and so I was like, if I had had options, I definitely would have taken those paid options. But you know what? Like, times are really hard. And one of the things, like, I was talking to one of our principal data scientists a while ago, and he's amazing. Like, he left where I work to like go fund a startup, funded a startup, didn't go the way he wanted, then he came back. I know, so he's just like really well versed, and even he sometimes at the principal level will struggle with like getting jobs. But what he said is like there is a simple formula. It's not easy, but it is simple, and it's just like do projects, be okay at lead code, and network. And it's like if you do that long enough, you will get hired. Like you actually like that's like maybe the only guarantee I'll make in this whole presentation. Like you will get hired if you do that, but there's no guarantees on timelines, and so it's like if you have kids, that makes that hard. Like I could definitely see you burning out of spare time before the it finally pays off. So like I have a really good friend Joe, and he like I left to go work, and he decided to get a master's in math, and it was like the exact wrong time to do that, and like that was like 3 years ago, and to this day he hasn't been able to break in. And one of the factors for him is like he actually helped me with Rootski a lot, so like I know he's pretty good at AWS, but he wasn't able to pursue that. He wasn't able to keep growing and keep staying in the process. And with his arrangement now, his wife works and he stays at home with the kids right now, and that ended up being what worked for him. And honestly, I think he likes that, and that's great. I just if he had wanted to work, that's what would have made me sad. Like if that were the reason that he quit the process, like because honestly, like I guess the whole point here is like you can manufacture your own tech experience. Like I talked to our CTO at lunch last Thursday. He was telling me like if you're an individual contributor, you can go home, you can code, you can like take tutorials and like online classes and stuff. You can build stuff, and you can level up as a software engineer. It's actually not the same for leadership. Like there's no way you can get how do you get reps as a leader outside of work? Like I guess he was like I guess you could like run your family with Scrum or something and like he's agile like but like I don't know, but he was commenting that as a leader he's actually a little jealous that as individual contributors like if you're in a phase of life, and honestly people outside the US tend to be willing to work harder, I will say. So like like if you're willing to put in those insane hours and if you can sustain that for a long time, like it'll happen. And also you don't even have to pace yourself that fast. Like if you're able to actually just do this part-time for 3-4 years, you could enter the industry as like a mid-level or senior engineer never having had a job. The question is, can you keep that up long enough? So immigrant mindset, yes, or just like desperate college student with a family mindset, like either one. Like let's see oh Amit, no I only DM people for interviews. All right, cool, that's fine. Like even then I'm like, well, you should have gone and checked their careers. Okay, all right, Amit, I tell you what, I'm on board with this. If you go to the career page first and you're like, hey Eric, just applied to this job, just want to put a name to a face, I love your content, by the way. Like, something like that, like something that shows like not only did you put in some work, but also like maybe know the person you're DMing. That I think that can go over really well. But again, like if it's what you got to do, send those cold messages. So let's see. Xavier said, "Are you familiar with the Berlin market for MLOps?" So like no, but like I see a lot of meetups happening there, and so I get the sense that there's like good tech companies in Berlin. So I actually Berlin, like when I think about good places to work outside the US, Berlin's like one of the first that comes to my mind just because I've known some people who've done internships there. So but I actually don't have personal experience with it. But if you could kind of age, first of all. What was your progression like in terms of learning? Actually, I think I like answering this question. So like, oh, Dave is typing something. Yes. Okay. So I did math. I did applied math, and so my degree was pretty focused on like algorithms. It was like the math behind data science. So that was like good, but it definitely wasn't enough because like the thing that helps you get jobs oftentimes is the software side. Dave, this discussion's been so pragmatic. Okay, good. I'm glad that's your reaction. Let's see. So let's see. Okay, so I had like this minor in computer science, and in my computer science program, I like learned Java, and there was one class where we made like a really basic Android app, basically following a tutorial from an outdated textbook. And we made like a backend REST API server for that Android app. And that was like the first project I ever made where I was like, oh my gosh, I could like code stuff now that people would actually find valuable. And so for me, taking that class, and I'm not saying you have to go to college, but that experience of writing a REST API and a front end together, that was what like, oh, and there was also some unit testing in there. That was where I felt like I had blossomed as a software engineer, but I still had a lot to learn. So then I was able to get the analytics internship. I did some hackathons and stuff, but mostly I was working on my personal project, which was Rootski, and that's a full stack app. That's like a front end written in React with TypeScript. It has auth, like sign in, and I set that up with like AWS Cognito. So there was like an infrastructure as code component there. And when I was learning that, I worked on the parts that I was like using at work. So like at work, we didn't know, like we didn't use any sort of infrastructure as code at work, and I was like, oh, I could maybe learn CloudFormation. So I learned CloudFormation and deployed my thing, and then like I learned that CloudFormation sucks, and so then I was like, oh, Terraform in CloudFormation. So then I like rewrote it in Terraform, and I was like, well, and then I was like, Terraform's lame for the sake of CloudFormation is lame. It's like this weird new language, and I was like, it'd be really cool if I could do infrastructure as code in Python. And AWS CDK, like Pulumi's a thing too, but man, like if you can get away with only using an AWS tool, AWS CDK is probably like the best open source tool on the market. I know that's controversial, but like the thing is, you can get started with it for free, and it scales forever for free. There never comes a point where you have to pay for it. So a lot of companies are really into that, and that's a really nice tool. That kind of like started me loving that. I also took a course on Docker when I was still an analyst. There's one by Brett Fisher on Udemy, and I stood up Airflow using Docker, like with Docker Compose locally. And so that I learned about like Docker and Airflow. So by the end of that, I know infrastructure as code. I know AWS. I've like taken some tutorials. I kind of am like a hobbyist full stack developer. Like I understand the front end now. And then and I also stitched stuff together. There like Postgres was a thing. Like my app used Postgres. So I knew how to use a database and build a full stack app. So by the end of all that, it was like what was really cool about that experience is like there are very few people that have actually built a full stack machine learning app end to end, including a front end. And so even with kind of minimal experience, so Tyler Folkman, he's my CTO, right? And like he had a course on MLOps, and he was like, "I'll give you a discount on your course. Like it'll only be $250." And I was like, $250? Like that's so much money. Which actually that's a really good price for like a professional course. Like I've come to learn, because actually when I do my boot camps, it's probably going to be a lot more than that. And so I go to take his course though. Immediately, some of the leadership stuff was totally new to me. And I thought that was awesome. But then he was like, "Here's how you build a Docker container, and here's how you like deploy it onto the cloud in like the most basic way." And I was like, "Oh my goodness! Like, what a waste of time! Like, I already did like a more advanced version of this through my full stack app." And so I actually asked Tyler if I could have a refund. He was totally cool with it, and I felt like I needed to justify it, so I sent him like the architecture diagram for Rootski. It was like he was like, "Oh, nice. Here's a refund." And then he's like, "Do you want to interview for Ben?" And like that was how I got my job at my current company. And so I thought the relationship was like game over, but actually he took it well. So like, but in so many conversations with people, even as like a relatively junior engineer, like even as someone who'd only been working like 2-3 years, I noticed that like I had a better understanding of MLOps end to end than like almost anyone I talked to. Like no one had built a front end and deployed it to the cloud and done the IAC and trained the model and done experiment tracking. And like that's not too hard to do. And my path was pretty windy because I like rewrote parts a lot of times, but yours doesn't have to be so windy. Like there's better tools now. And if you want, I can give you some recommendations on just good ones to use. So there's something to be said for breadth. Absolutely. Like for end to endness is really good. I will say after that, I got really excited about end to end people. And I was like, I'm only going to hire people on my team who've like done things end to end. And I think that was actually a mistake. Now, you know, we have people on our team who like know how to do things end to end. And so now I've kind of shifted, and now I look for people who are like, yeah, I kind of loosely understand end-to-end, but more like experts at like a few parts of the component. Like for example, we haven't set up really robust monitoring for a lot of our projects yet. So when we're looking to hire, like it would be great if we had like an expert at monitoring. You know, if that was like one of the things they're an expert at, that'd be like really good because I think they would round us out. So I guess there's a lot to say for being like for going deep too. So let's see. Because it became a band to work with this, so many people having. And you have zero clue on what they want. What are you learning now? What am I learning now? Well, I'm gonna make a boot camp on software on AWS. So here's something I've noticed. Like I talked about the monitoring stuff. I have almost never met an engineer who's actually deployed a REST API and fully set it up with monitoring and like alerts. Like end of story. Like to this day, very, very few people that I met have actually set that up, which is like crazy. Like What was really weird is like even 2 years out into my career, I had done like one project with that, and it was like there were people who had been on the team for 6 years. Like for some reason, I knew more about like dashboards and alerts than they did, and I was like, this is weird. And I think like, so I think that's like so one point here is that like, by the way, if you want to like differentiate yourself, even just generally in software engineering, you will like if you have used New Relic or Datadog and like deployed a REST API and like set up alerts with it, you would like blow people's minds. They'll be like, how on earth did you think to do that? Like, I've never seen anybody does that. So nice, Mert. Dude, yeah. Mert, if you want to work together, I would totally do that with you. So there's a really, really, really cool project that just came out a couple years ago called OpenTelemetry. And it's awesome. Like, so back in 2019, if you were learning how to like monitor Airflow DAGs or monitor REST APIs, you would find stuff about Prometheus and StatsD. Like, those are two services that you can stand up. They're like Docker containers, and they're also SDKs that you can like put in your Python code, and you can log metrics. So like every time a customer buys something, you can say purchases +1, and like you can use their SDK to say purchases +1, and that'll like get logged in the metric server. So then you're storing that metric, and then you can like build alerts off of that and stuff. And Madhav, what is the basic level of monitoring? Oh, that's a good question. So actually kind of what I'm saying now, this definitely ties into that. Like, can you use one of the SDKs to like set up alerts and track metrics in any code, machine learning code or not? Like, that's really good. And then so you used to have to get the StatsD SDK and fill your Python code with like StatsD calls or like the Prometheus SDK. And then New Relic, if you're going to buy New Relic, the company, which is like a lot of money, there's a New Relic SDK, and then you're logging the same metrics with that. And also Datadog has an SDK. So like it was really scary to learn about, because you knew that you would be really locked in. Your code would be riddled with like, first of all, you'd have to learn their SDK and become an expert at it. And then you'd have to fill your code with these calls to it, these references. So if you want to switch from New Relic to Datadog, like now you have to relearn Datadog, and it's like terrible all over again. So it's really hard to get in. OpenTelemetry is this project that makes one SDK. They have one metrics format. You can put it in your code, and you can switch between New Relic, Datadog, and like all the other monitoring vendors, like easily, like instantly, like zero lock-in. And so like at that point, Datadog and New Relic become like a dashboarding layer. Like, okay, I'm using OpenTelemetry to like count how many purchases I get, and now I can pick my favorite dashboarding tool of choice to like visualize that, maybe like do some alerts. So Donna, OpenTelemetry with Python still doesn't have as granular as it does Node. Yeah, okay, that's way cool. So you must. So I'm guessing you're like more experienced than Sedona, because that's a pretty experienced question. Like, yes, that's true. Like OpenTelemetry in general is like still sort of in beta. Like, it's still considered like unstable. But even as recently as like a few months ago, like major portions of it became stable. And I have a whole like article I've written on lots of MLOps tools and processes, but one of them is OpenTelemetry. So I could send you guys some stuff on that. And yeah, you're right, Sedona. And interestingly, Bento ML has gone all in on OpenTelemetry, and like you can kind of see some of the gaps there. Like I tried to instrument a fast API app with OpenTelemetry. If people don't know what that means, basically I was trying to use OpenTelemetry to like fast API. If you get an error, you can count how many error codes you get, and then you can have an alert where you're like, if I get more than 10 error codes in 60 seconds, send me a Slack message because something's probably wrong, you know? So like, and I noticed that when I used New Relic's proprietary CLI tool or whatever, they gave me really granular data about that. But when I used OpenTelemetry's tool, it gave me a lot less. But definitely over time, that's going to get better. So it is a little lame. But I will say, if you learn OpenTelemetry, you'll still blow people's minds. And I still think it's a good tool to invest in. So someone asked what I'm going to learn about, what I'm learning about. I'm learning all about that and like observability and stuff. And I'm hoping to like put it in a course where we like deploy a Python REST API together and like set it up with OpenTelemetry, like maybe make some alerts. But I'm realizing that could double the length of the course I'm thinking. So I'm thinking the first one I do maybe isn't going to cover monitoring. Maybe it'll just be like AWS stuff. So yeah, what's the basic level of monitoring? Yeah, Madhav, it's just like, is my service up or down? That's like level 1. And then the next one is like, how at risk is my service of going down? And that's like, okay, now you have to track more sophisticated metrics. Like, are we going to run out of disk space? Like, are we going to run out of RAM? Like, is the CPU too small? Do we need a bigger one? So then you have to start tracking like hardware metrics, which actually is it's actually pretty easy to do. Like any monitoring tool, you can start pretty quickly. And then you should like create alerts on that, you know? And like a lot of people have never set up alerts before. Like they've tracked the metrics, but they've never actually like actioned on them. And setting up alerts isn't too hard. I don't know. It's a little hard to set up something like Grafana, which is like the open source version. So for alerts, honestly, I'd recommend grabbing something like New Relic and just using their free tier. Like, I'm pretty passionate about self-hosting stuff, but like observability stuff, I just am not, you know, I just kind of want it to work. And so like, and it's now that open telemetry is a thing, I'm more confident than ever. If you learn New Relic, that knowledge is going to transfer with you to Datadog or Splunk or whatever. So I don't know. So I don't feel too bad about like investing really deeply into one of those SaaS tools. Yeah, and then after that, the biggest thing is actually custom metrics. So like there's generic things that'll track your hardware utilization, but nothing, no product that Databricks could ever offer you or New Relic could actually track the metrics that are specific to your business application. So like if you have an application that tracks if you have an application that people interact with to like buy stuff, you're the only one who knows like, oh, number of things purchased is something I should probably track. So I should probably like add some things to my code to like track that. And so that's called like a custom metric. And that may be the most advanced thing is like custom metrics. And like, a lot of people have never done that ever, like in their whole career, and it's like, and it's a pretty powerful thing to do. It's like most teams that you walk into could benefit from having some custom metric stuff set up. I don't care if it's a data engineering team, data science, whatever. Like, so it's one of those areas where like you can easily walk in and be the most knowledgeable person about like observability and like really make a name for yourself. And by the way, if you're really good at, let's say you're really good at observability and really weak at MLOps, if you're good at observability, there's an argument that you could add value like from day one when you walk into a company. So there's something to be said for that. IAC is kind of similar. Like, so I don't know. So if you want ideas on like areas of depth that are kind of like things you don't normally see in entry level people that could maybe make an impact on a wide variety of teams, we could definitely talk about that. Let's see. In terms of MLOps, how do you decide when to send alerts for model performance? Yeah. So degradation's a thing. Like the example of like COVID, you train a model, it's recommending toilet paper, and you're like, oh my gosh, it's 2024, we have the same model, and why is our revenue not as high as it was in 2020? So this is really hard, but like, because how do you know if when you make an inference, the inference was actually good? The answer is sometimes you never can, but sometimes you can sort of like later on get a ground truth. Like a month later, you can be like, hey, a month ago we were like recommending toilet paper, and we've noticed that our revenue's gone down. So that could sort of be like a ground truth. You could be like, interesting. Like the conversion rate for the toilet paper recommendations model is like dropped, and so like that is like a ground truth that you can react to. And honestly, I've never set that up in my life. I would be really impressed if you had done that before. Like, I don't know, like we currently actually don't have use cases for it. That's the thing. But if we had it, like I'd be pretty impressed. But the thing is, like I said, if you just retrain your models regularly, that is solved. So the only time when you really need the fancy alerts for feature drift is when it's so expensive to retrain your model that like that's not an option. So how do you decide when to send alerts though? Like oftentimes I would say send as few alerts as possible, and like that's a really obvious answer for people who've thought about alerting for even like more than an hour, because like you don't just want alerts to like be filling up your Slack or your phone with spam. So you want to send as few as possible. So you want alert systems to automatically trigger whatever the remediation of the alert is. So for if you buy a monitoring tool like YLabs and you have an orchestrator tool like Metaflow to train your models, YLabs has an integration with Metaflow such that when it detects drift, it can like trigger a DAG that you specify. So your monitoring tools can actually just trigger a retraining right then automatically, and that fixes the problem. Yeah, you said apart from just model uptime, how do I define model drift, given that there could be a variation in model performance based on the application? Yeah, like I don't know. It's like a whole big topic. So anything I say is probably stuff you would have thought of yourself anyway. But like what does drift even mean? Or like actually so drift is probably the same whatever kind of model you're doing. Like what are the columns I put in, and I'm tracking the distributions of those things. And like if age is suddenly negative, that's a pretty bad drift. I'm like, why is age negative? That's probably invalid. But the other thing to think about is just risk in general. So like why have we at Ben Labs not invested more in monitoring? Well, like we recommend people like creators to look at and follow on YouTube. Like if we recommend a creator that's boring, like that's like the worst case scenario. Worst case, we recommend a creator that's boring to someone and they just like leave. It's not like we're deciding who can get a loan and who can't, like, so a really, really good thing to do is decide, like, so one of my big pieces of advice is like, for a personal project, get real customers, like get real users to use your thing. Like, even if it's just like your friends and family, like do that. Just like anyone. I mean, obviously it's great. Like for my thing, Rootski, like there are real end users and like there's people who go there and like search some roots and stuff. But like understanding your usage can be a lot simpler than that. So then the question is, how bad? Then you should do a risk analysis, and I think this is really cool to like see a write up on, like even if it's just like a couple of sentences. It's just like, okay, so what's the worst thing, or what are the bad things that could happen if my model like does badly? Like, what would it mean for my project to like do badly? Like, what's the maximum amount of harm I could do to a user? Oftentimes the answer is like it's actually like trivial. There's no harm, but you know it's cool to see that you've thought about it. And when you have that answer per project, then it becomes clear what to set alerts on. I don't know. I guess going back to data drift as an example, like if you catch data drift for like a fraud detection model, you should check that out ASAP. Or like if you have ground truths eventually and you find out that the model's not performing well, you know, you should check that out ASAP too. Maybe a better example though is like, I don't know. I actually don't have a better example. Yeah, it really just depends on. I don't think there's one tool that solves it. It's just like when you know what the risk is, it'll become very clear to you like what a good way to catch it is. Okay, this was my last question. Respect Pro Max for your time. Hey, thanks for saying that. Yeah, connect with me on LinkedIn when you leave. Let's see. Yeah. I don't know. If there's more questions, I mean, there's still people here, so. Everyone these days are looking for Rockstar interns. Yeah, Rockstar, Wizard, Ninja Turtles. Yes. Yeah, let's see. Also, I really like, hopefully this whole discussion on monitoring really makes you think like, wow, that's a software engineering concept. Why is an MLOps expert, I'm not saying, why is an MLOps person talking, like emphasizing a software engineering concept so much? And the answer is because it's actually software engineering. That's the answer. So, just looking through one new message. Yeah, whoever CloudTap is, I'm just glad you're here. Let's see. I don't even know what Mamba mindset is, but let's see. Yeah, I mean, I guess I can do a plug. Like, so I have a Udemy course. People really like it. Like, I guess I'm an influencer kind of person, so I'm gonna tell you to buy my course. But like I said, most of it's free anyway. If you think so, I was making a self-assessment today for one of the more advanced courses. I've never written unit tests, or if you want to learn about advanced unit testing, if you want to learn how to create projects from scratch, like just from a software perspective, just like how to write Python well, or like even use Git or GitHub or continuous integration or continuous deployment, continuous delivery. I mean, what are some other things? If you've never heard of semantic versioning, that's definitely something you should know about. There's a whole debate in the world about whether poetry is the best thing to use, or pip tools, or like what's the best way to manage virtual environments, like linting, stuff like that. Like we had an intern, like the reason I made this course is because a lot of people where I work are like your classical data scientists, right? And like they don't really have an engineering background. And that meant that most of my screen sharing time with them was literally just like type this command into the terminal, like print out the contents of the file, like write cat, and then the file. No, it's like cat, and then the name like .txt. Like it was like that was the level of collaboration that we had. So I wanted to make a resource they could go to just like get all that software engineering onboarding just like pretty easily. And so we had an intern, and I was actually a little concerned about this intern. I won't say their name. You might actually know them if you follow me on LinkedIn very much, because he's pretty like active on LinkedIn. But yeah, I was worried because his output wasn't very good. And part of the problem was he was part-time, and so it was hard for me to tell, like, is it his technical skills? Because he came out of the same math background as me, so I kind of knew, you know, I kind of, as a math grad, I was like, yeah, math grads don't have great technical skills. But also he like was part-time. And so like before he came back, like there was a period of time that he went back to school, and so he had this break, and I was like, before he came back, I actually assigned him to take this course before he came, and it was like night and day difference. Like the level of conversations that we were able to have about engineering were just like so different, and it's helped his career a lot. I've heard similar things from other people. If cost is an issue, just tell me and I'll send you a free code. Honestly, like the reason I made it was to get it out there. Like there's probably no way I'll ever make my money back on it, because I spent 9 months on it and I've only made like $2,000, which is like, if you're a senior engineer, that's so far away from good ROI. So like my main concern is that people just take it and learn. So definitely, Dave, I know there's almost 2,000 students now. It's awesome. Anyway, and people like it. Like actually my favorite courses on Udemy have about 4.7 stars. It's almost like as good as you can get. Because after a point, like, no, I don't know, like after a point, the average, you can never really average higher than that. So it's, it's rated as highly as my favorite courses, whatever that tells you. So this summer, I'm hoping in June, I want to do my first cohort-based class ever. It was too high. Wow. Oh yeah, thanks. There's a discount code. I think the discount code makes it like $20 today. I think normally it's like 35, but again, even if that's an issue, I'll give it to you for free. Like my main thing is like if you can convince me that like you're actually going to take it, consider it done. Like you can have it. So, and also if you finish it and do the final project, I'll like send your final project to me and I'll give you a shout out on LinkedIn if that's motivating to you. So, I'm going to make a course. So I told you about my journey. I like started with Python, made Vrootski, learned infrastructure as code, then did MLOps. I kind of want to build like the ultimate MLOps bootcamp. And since this, like, if you think about it, the first course I made, it was like really basic, and that took me 9 months to create. So I was like, I can't do that again. So to be completely honest with you, the reason I'm going to do this one as a cohort-based bootcamp is because it takes me less preparation time. Like, it's easy for me to have conversations like this. Like the difference between making a product that can be completely self-served versus a product where I can like talk to you and give the students hand holding to like ensure their success is like a lot. It's like months of effort. So my plan is like, honestly, it's not going to be super polished. I'm just going to like take you through a project and stuff. But it's going to be live and we can make sure you get it done. And then later, hopefully I'll be able to turn it async. So part 1 is going to be just like, let's put a REST API in AWS. Let's get it unit tested. If we have time, I'll show you how to Dockerize it and use an alternative to Kubernetes called Elastic Container Service, but we might not have time. And then round 2 of that would be a really deep infrastructure as code project, like insanely complicated. And if you do this one, like some of the core creators of CDK like knew about the project, and I even showed it to them after, and they were like, "This is impressive." like I think they think that this project actually sort of pushed this infrastructure as code tool like to its actual limits. And so I kind of consider myself after this exercise like maybe one of the best infrastructure as code people out there. So yeah, I think well, it basically is a website where you can click a button and deploy a Minecraft server for yourself and your friends. Like that's what it is, and yet it's really advanced. So it's basically how to build a platform as a service yourself. Anyway, so that was gonna be crazy. I think that'll be like round 2. After that, I think it will finally create an MLOps course with Maria. Or we're talking about collaborating. I hope that works out. But like, and the thing is, I'm hoping that people will eventually take these courses sequentially, and it'll be like, yeah, we learn all this Python stuff, and then we learn MLOps, and by the end of the bootcamp, they realize that like literally 80% of the MLOps stuff really was like all the IAC stuff. So anyway, that's like my ultimate goal. But at the same time, if that's not your speed, or like you don't want to take a course, like I'm pretty available on LinkedIn, so you can just shoot me questions always, and I don't know, I'll do my best to help you. So thanks for that. Yeah, so
my gosh, this was probably this was the juiciest, the most one of the most valuable classes. I consider this a lecture session because I heard so many tools today and the integrations. My brain is like, oh my god, thank you for like giving so many new data points that I can actually use and do something about it. So I'm really happy that you joined. I think we should like, does everyone have Eric's LinkedIn? If not, we're gonna share. Please, somebody share his LinkedIn, and definitely check out the course. I'm gonna do the course now after this whole like. You convinced me to learn infrastructure as code. You convinced me to try Bento ML. You convinced me to like always use VS Code. I mean, so many other things. I don't know.
Nice.
What
so funny. Yeah.
Learned what you learned from today's session. Write in the comments section. What stood out for you?
Like Zuckerberg did the lecture on Harvard, whatever. Thanks, Mert. Mert the Turk. Yeah, so let me think about this. So, yeah, I guess the final takeaway is I don't really know how to tell you how to get a job. I just don't. It's just so hard. And so if you pursue the things that I just told you to learn, it might technically not even be the most efficient path to getting a job as fast as possible. Like I think it may be the most efficient path to like become a well-rounded, just good engineer. And I'm hoping that if you're a well-rounded, good engineer, that means you can get a job. But it's not like, I don't know, you might actually have better experience if you're just like cram leak code or like, I don't know, like there's other ways to potentially get a job faster. And so this advice is really for people who like are really, I think it's more reliable to sort of like play the long game and like just level up. So cool. I'll send some links on Discord, and if you want to subscribe and hit the bell on my LinkedIn profile, I'll do a post and post like a bunch of resources, and then after you see that post, you could totally unsubscribe. That's fine. So
awesome.
cool.
Well, perfect. Thank you so much, Eric, for coming. Please create a new thread somewhere in one of our channels and include all of the links. I'm sure you have plenty of resources, but I'm so happy to have you in our community. Please come in from time to time and share your wisdom in the chats. And yeah, we're gonna see you soon, and let us know whenever you launch course in the cohort. We're gonna be watching you everywhere. That's
nice.
awesome.
Yeah, and I'm excited to get to know you guys too. Like, yeah. Anyway.
Awesome.
Cool. See you guys.
Thank you. Have a great weekend, everyone.